In this video, I'll cover the Year 9 Linear Graphing Applications Test Preview. So these are the sorts of questions you should expect to see at an A and B level. I'll put some time tags below for you so you can skip the question numbers, or I'll put a description of what the sort of question is so you can skip to the sort of question you need help with. To tackle this test, you'll need a few formulas. You'll have to remember the typical linear formula. So you know that all of these equations are going to reflect y equals mx plus c. So you've got your gradient here, which we've talked about in the previous video, and you've got your constant on the end, which is your y-intercept, most importantly. Now, there's two new formulas for this one. We've got an interest and an account balance one. And interest is if you borrowed some money or if you invest some money, it's the extra money that you'll have to pay back, or it's the extra money that you'll earn by investing it in something. So as we go down through these, I will be interest, which we've just talked about. Your account balance is how much money is in your account. The principal is the amount of money that you start with. So that's the amount of money that you borrow. So if you take out a $10,000 loan for a car, that's the principal, the $10,000, and the interest is the extra on top of that you'll pay back. The rate is the interest rate, so how quickly the extra money accrues, and it's really important that this is always put into the formula as a decimal, okay? No excuse, no sort of change to that. And the other thing is time. This is always expressed in years. So if you're only taking it out over 6 months, you can't put 6 in. You're going to have to put 6 of 12 months, for example. Okay, so as an example here, 6 months would go in as 6 of 12 months, so it goes in as 0.5. Well, let's have a look at question 1. This one has an account that earns interest, so someone's invested $36,000 into an account. They've done it for 5 years, so we've got our time, and we've also got our rate. Now, straight away, I'm going to be careful with the rate. I know that I have to convert this to a decimal, so I'll do that straight away so that that's nice and clear. And I know that this one's going to be time, this one's going to be rate, and this one's going to be the principal, because that's how much they initially put in. And what it wants me to do is fill out this table over the 4 years. So we'll start by doing that. So we'll use our formula for account balance. So the account balance is going to be the principal amount plus the interest that's accrued. So we'll start subbing in our account balance. If our principal was 36,000 plus the 36,000 multiplied by the rate multiplied by 1, and I'm choosing 1 because it's for year 1. Even though it's invested over 5 years, we only want the answer to the first one. I'll put that in our calculator, and we'll get $37,440. We can run it again. We'll do it for 2 years. So if we've got an account balance equals principal, plus the interest, PRT. That's going to be this time 36,000 plus 36,000 times excuse my touch screen, 0.04 times 2 this time. This time that will come out as $38,880. And we'll write that into our table. Now what I've noticed here is I could keep running this formula for the next 2, but I'm a bit lazy to do that. I can see that each time that we jump, we're jumping by $1,440. So what I can do is it's linear. It will always increase by the same amount. So I can just keep increasing this by just adding $1,440 on each time. and just finish filling out this table a little bit quicker because I don't want to waste any time during my test. But I will get stuck when I get to question B. This is where we need to use the formula because it's an unknown number and I'd have to keep adding it on, and they could ask you any number here. So let's jump back to the formula here. Principal plus interest, and let's sub in our values. My account will be 36,000 plus 36,000 times my rate in decimals times the number of years. Put it in your calculator and it will be $44,640. The last question here, it's for 50 months. So when we do this one, this is the trick question for the time here. Some people won't know how to write this in as time. So let's just keep with our formula. We've got still the same principle. Still the same rate. But if we have to talk about 50 months in terms of years, it's easiest to say, well, there's 12 months in a year, so we're going to have 50 of 12 months. And you can put it in your calculator like this. If it hadn't have been months, if it had been days, remember there's 365 days in a year, don't worry about leap years. And if it had been expressed in weeks, there's 52 weeks in a year, so you can always express it that way. And your calculator will let you know that the answer to this is 42,000. So fractions are a great way to go on questions like this. All right, moving on. Now we're graphing. So we've got plenty of information from above there. What we need is we need a good scale on this graph. So if I just zoom out so we can see what's going on here. It doesn't really tell me how long I have to graph this for. So usually time will go down the bottom and the amount will go at the top, just like in science. So you've got your dependent and independent variables, and then we might make that 10 years along the bottom. So this will be in years, and the amount will be in dollars. And we better get a scale for the side. We want one that's nice and easy to work with. I can see that those numbers are sort of approaching, getting towards 50,000, and that will work nicely on our graph. So we might make this 50,000. This way we're using the graph reasonably efficiently, but we're not making it difficult for ourselves. So that's the 25,000 mark there. And this is the 50 up here. I'll chuck a 0 in down the bottom. I like to start from 0 if I can. Okay, and now we've got a constant, so we'll start to put this in. Our principal amount was $36,000. So that's what our y-intercept is going to be, which is going to be roughly there. And then all I need now is just one other point. Remember that this is linear. I don't have to go through and mark every single point. So let's just go and choose one at random up here. Let's say that we choose year 4, where we've got $41,760. So I'm getting that from here, okay? Doesn't matter which point I choose, but if I'm at year 4, then I'm the 4th line across, and 41,000 is going to be roughly here. I put my mark in here, and what I'm going to do is I'm going to just label this one for my marker. So I'm going to say at year, sorry, not at year 5, at year 4, I'm at 41,760. Okay, and then all I've got to do is grab my ruler, dot to dot. This is a continuous line, it goes on forever, so we'll just keep it going. If he kept that money invested, it's just going to keep growing at the same rate. And that's our answer finished. All right, something slightly different now. We might need to add a few more formulas to our list at the start. So this one we're trying to find the midpoint. So we want to find halfway between 2 points. The problem is this time we've got some letters in there as well. Okay, so in fundamentals, what they were doing was they were asking you to find the midpoint, but now we know what the midpoint is. So let's give these some values. I'm going to call this set of values here x1, y1, call it as a coordinate. I'm going to call this one x2, y2, and I'm going to call this the answer, x, y. Now my midpoint formula is that xy will be x1 plus x2 divided by 2, so the average of those, and y1 plus y2 and the average of those. So I'll sub in what I've got. I've got an answer of a half and minus 8. And then I've got x1, which was 4 plus a. So I got that from here and here. Divide by 2. And for y, I've got 6 and b. So again, I got that from here and here. And that's all divided by 2. And this is a bit of a funny old formula, this one. What we might do is we might have a look at breaking it down, because really what we've got here is this equals this, and if I change color, this equals this. So we might do it one step at a time. If I take the first part of this, so I'm going to do the x's first, I know that I've got 4 plus a divided by 2 equals a half. And now really it's just balance method. Let's multiply by 2 on both sides, and 4 plus a will be 1. Let's subtract 4 on both sides, and a will be minus 3. So I found out what the value of a is, and now I want to find the value of b. So I'm finding my y. So this time I've got 6 plus b divided by 2 equals minus 8. So that's coming from the blue highlighters. Same process, we're going to go balance method to solve for b. So we'll times both sides by 2, and what we'll have is 6 plus b equals minus 16. Let's subtract 6 from both sides this time, and we'll end up with b equals minus 22. So I've got my two answers here. I've got a is minus 3 and b is minus 2, and I have found a and b. Moving on, question 3. Alright, this time we're being asked for a gradient. So we need our gradient formula. And our gradient is our rise over our run, so it's y2 minus y1 all over x2 minus x1. I'm going to assign these values just like in question 2. So I'm going to call this one x1, y1, x2, y2. It doesn't matter which you call which, just as long as they stay as pairs. So x1 has to be with y1. And now all I do is I just sub those into my formula. So I've got y2, which is 20c, minus y1, which is 6c. I've got x2, which is 12, minus x1, which is 8. So all of those numbers came from up here. And now we'll just keep solving. I've run out of room, so I'll just scoot up here. So I've got 20 groups of C, take away 6 groups of C, leaves me with 14 groups of C. And 12 minus 8 is 4. I can simplify that fraction a little bit. So M is 7C on 2. Looks a bit strange as an answer, but if you have a look back at the question, the answer will be an algebraic expression, or in this case, a equation. Technically, an expression is just 7c minus 2 because there's no equal sign. All right. This one's going to be long. This one is the distance formula, but it's giving me 3 points, and it wants me to prove that interval AB is not the same as interval BC. Okay, so that means the distance between A and B and the distance between B and C is not the same. So we'll need to run the distance formula twice. We need the distance formula, that is, that D equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. This is really just Pythagoras. So let's have a bit of a look. In the first instance, we're working out AB, so I'm going to call this one x1, y1, and I'll call this one x2, y2. Same as the midpoint formula. It doesn't really matter which pair you put where, as long as they stay as a pair. And now I'm just going to sub into my formula. So AB will be the square root of x2, which is 5, minus negative 2 all squared, plus y2, which is 6, minus 1 all squared, which gives me 7 squared plus 5 squared, which is 49 plus 25, which is the square root of 74. That's not going to square root neatly. It's going to give me a horrible decimal. So I might just leave that at this stage, just like that. And then for the second round, I'm trying to do BC next, so I might as well leave B as x2, y2 this time, and I'll make this one x1, y1. That'll sort of prove that it doesn't really matter what order you put them in, if you like. So this one is going to be BC, is going to be the square root of, and I'm using the same formula, so x2, so 5 minus 9 squared, plus y2, so 6 minus 22 all squared. So that's going to end up being the square root of minus 4 squared. Don't forget your brackets. You don't want your calculator making a mess of negative numbers on you. What's this one going to be? Minus 16 all squared. And I might use our calculator at this point, and that's going to give me the square root of 272. Now, have a look. These two numbers, even if I put them in my calculator, are definitely not going to be the same. So, therefore, AB is not equal to, you can write is not equal to if you want, or you can just put a strike through a equal sign like that and it means the same thing. They are different. Okay, and last of all, question 5, another long one. The height of a chairlift is given in the table below, where D is the distance from the base of the platform. All right, so straight away we might give our chart over here some values. Distance in meters is going to be down the bottom, and height is going to be on my vertical axis. It's asking me to find a linear equation describing the height of the chairlift in terms of its distance from the base of the platform and graph the equation. Okay, so we've decided that H is going to be our y-axis and that D is going to be our x-axis. So remember that all of these formulas will follow the rule y equals m mx plus C. Okay, so in this instance, so we don't get ourselves confused, that means that in this equation, H is going to be MD plus C. And we'll just swap them in accordingly. So we should be able to find the constant pretty easily. It's sitting here looking at us right in the face. When D is 0, H is 26, or when X is 0, Y is 26. So the equation can start off quite nicely. Height is going to be an unknown gradient at this stage plus 26. In other words, the chairlift is going to start, up here somewhere above the ground and go up from there. How do we find the gradient? What we need to do is we need to find 2 points on this and use our gradient formula in order to find it. So remember, our gradient formula is y2 minus y1 over x2 minus x1. So all we need to do is pick a pair. I'm going to pick the first two because they're nice small numbers. So I'm going to call this one x1, y1, and I'm going to call this one x2, y2. And all I need to do is just sub them in. So they're going to be 28 minus 26 all over 10 minus nothing, which is going to be 2 on 10, or better written as a fifth. And so now I've got my gradient as well. So my final equation for this is going to be that the height of the chairlift is going to be 1/5 of the distance that it's travelled plus 26 meters. And it says, what does the intercept? So this is question, and I think we need to graph it too, actually. I better not skip that. Yes, graph this equation. Right, okay. So we've given ourselves H's and D's. Remember that we chose those based on the fact that the height of it, okay, is the dependent variable, if you want to link this to science, and that the distance is the independent. And it does matter which axis gets which, okay? So distance and time usually goes down the bottom. Now, let's give this an axis. I can see that the distance travelled is 50 meters and I've got 10 intervals here, so I'll make this 50 and make the most of the graph. And I can see that the height gets up to 36 meters. I'm getting that from here. That's close enough to 50 that I won't confuse things. So I'll put that one as 50 as well, and this one will be 0, both in meters. So we had a starting point of 26, so that's going to be around about here, just over halfway. And we only need to choose one other point. Remember, it's linear, so don't bother plotting all of them in. Let's go for the last one. When it's travelled 50 meters, it's 36 meters high. So let's go 50 meters. It's going to be 36, which is going to be roughly here. Grab a ruler, neat as you can, dot to dot. Might give this point here a coordinate for my marker, just so I don't ditch any marks unnecessarily. We'll call this one 0, 26. And that's drawn. Okay, now question B, what does the intercept with the vertical H represent? Well, often people write here it's the y-intercept, which is true, I guess. But what we're saying here is we've got to go back to the question. It's a worded question, and it says the height h above sea level of a chairlift. Okay, so what does it? What does the intercept represent? It represents height of the base of the platform above sea level, or the beginning height of the chairlift above sea level before it starts moving. Something along those lines would be perfect. And then the last two questions are just straight substitution questions. So find the height of the chairlift when it's 29 meters from the base of the platform. You've written a formula up here at the beginning of the question. It's now time to use your formula. So you've got that the height is a fifth of the distance plus 26. And this time you are given the distance and you're trying to find the height. So it's just substitution. So the height is 31.8 meters. And in the second one, you're using your formula again. So you've got that the height is a fifth of the distance traveled plus the 26 meters that it started at. But this time, you've got the height and you're looking for the distance. So this one will be 32.5 equals a fifth of the distance plus 26. And this time we'll need to use a bit of balance method. So let's take 26 from both sides and we'll end up with 6.5 equals 1/5 of the distance. And then if we multiply by 5, we'll find that the distance is again 32.5 meters, only through coincidence. Don't forget your units on these ones. And that's it.